why should we use a shell? So why do we need to learn how to navigate and write functions in using a shell interpreter? Why do we just use a mouse and click on it's like a web page or some sort of a software to perform RNA-seq pipeline? The reason is because most of these bioinformatics tools are designed to work through the command line interface. There are several good reasons for it. One of it, which is these packages, these softwares always undergo upgrade, and it's very, very fast to roll out update when your code is designed or written in, let's say, Bash or Python or R. It's very fast. Once you have an element of a user interface, it gets a little bit more complicated because you have to go through a couple of testing, and it take like maybe months before you roll out a new software. So that's why a lot of these tools that I use can have updates every few weeks. As long as there's a bug, you can see an update. And then you can also, through using shell terminal, you can automate your work. You can actually write scripts that perform repetitive tasks over and over again in one way or another, making it less boring because you create a script and let it run in the background, and you sort of like look at your like your product run and see that it work. It gives you this kind of joy, satisfaction that you create something rather than doing something, if you know what I mean. It also makes your work less error prone. So if you do have a foolproof script, you are sure that you are not going to make any mistake in terms of syntaxes, in terms of file namings anywhere within the script, because it's already set in stone. Also, very importantly, if you were to collaborate and perform a pipeline across different institutions, you want to make sure that your work is reproducible. You don't want to use a software or a set of tools which has different versioning, different different outputs, because then the comparison of your data would be very, very different. So that there is several ways to manage version control. And I hope in the future I can talk about this if there's enough interest in this. It's actually a very interesting topic, actually. And last but not least, we are now moving to a different era of computing, where we are now using cloud computing or offsite computing, such as using Amazon Web Services. Google has their own cluster. Even us in Kings, we have the Roslyn cluster that we can actually use to perform computation. And most, or not even most, all of these cloud computing do not have a user interface. You do require knowledge in shell and interacting with the cluster using the shell terminal. So several good reasons to learn shell. By the way, don't worry. So we're gonna go through the code right now. If when you're ready, you can open up terminal on your Mac or Git Bash if you're on Windows. So I'm going to share my my terminal right now. Let me see. Yep, this is share. All right, hope you can see my screen. I'm going to set my screen a little bit just to make sure that I see the chat up here and see any reactions. I think it should be okay. Okay, so I have a chat, I'm ready. So on the Mac, if you are not sure how to open up terminal, the fastest way is to do a spotlight search. So you can press Command Spacebar and search for terminal and then click enter. On the Windows, for those who are using Windows, you can search for Git Bash at the bottom of your window, in the search bar on the bottom of the window, and open up Git Bash, and you should be able to see a window that looks something like this, something like the window that I'm showing right now. If you do not see this, please voice out your problem now before we move on. Okay, so generally, I think everybody seems to be fine. Let me open up the participants as well, just to make sure. Okay, cool. So we're gonna start and input and play around with some of the commands in terminal. Don't worry if you can't catch up. Don't worry if you miss out certain code. I will paste certain set of sections of the code into Etherpad so you can refer to it very quickly if you sort of miss out and lag behind. I will also show you a way to save the entire history of code that you have written today towards the end of the class. So everything is logged because we're not going to use a script today. We're going to directly input commands into the terminal. And also in the coming few days, I will send you the code that I've written today with a little bit of illustration, a bit of notes so that you can benefit from what I have to say during the workshop. Okay, so your terminal might look a bit different from mine. But generally, you have several information such as the user, current user of the terminal. You also have this very weird sign, it's called tilde, and then this basically tells you the current directory that you're in. And this, sometimes it might be a bit cryptic, sometimes you might not be sure where exactly you are in terminals, because when you open up terminal, there is a default directory that you open up to, but sometimes it can be a little bit different depending on whether you're opening up tabs or whether you're opening up from different application. But this gives an idea of where you are right now in the shell terminal. The command to print out this directory explicitly is called pwd. So I'm going to type the pwd. It's short for print working directory. And if you press enter, it tells you exactly your current working directory. So this is what we call as a path. Because this is the position or the location of your working directory in your entire file system. Okay, I have a question from Ali. Sorry, so you're saying bash -3.2 That's fine. That's fine. So the dollar sign that you see here right before, like when you before entering the command, is what we call a prompt. This sign tells you that the terminal is ready to accept your command. It will change depending on whether your command is complete or not. But if you see a dollar sign, it's actually good to go. Okay, I'm gonna share with you a link to several images. I'll just paste this on Etherpad so you can have a look. I'm also probably gonna show it on my screen as well. Let me share this quickly. So the link basically gives an idea of the file system, how the file system looks like on both the Mac and the Windows. So if you can see from my sharing screen, you are currently, if you're on a Mac user, you're currently somewhere here under users. Most of you should be here. But then there are a parent directory above that, including users and also root. And then there are subdirectories under root, which contain other sort of code and other files, such as applications. And if you have a USB thumb drive plugged in, you have another directory called volumes as well, which is it's actually quite convoluted. I'm going to show you exactly how it looks like. On the Windows, it does look a little bit different. It doesn't start with root, but it starts with the volume or the C drive that you're currently working on, and the user works in this user directory or document settings directory, usually here. And then you have program files and other system files in Windows as well. For those using Git Bash, I'm gonna show you a way to actually go into root. You don't see root in the image I showed you just now, but then because Git Bash sort of create this UNIX system, UNIX file system, you will see how the root looks like on your computer. So I'm gonna share my terminal again, and then we can continue. Cool. So that's print working directory. We can also change the working directory to some other directory that we want. So I'm going to go ahead and change and dive into the root. We're going to go dive deep into our file system, and we're going to type cd, which is short for change directory, and we're going to type this. I always confuse between / and backslash, but this slash, which actually represents the root of the file system. Okay, this is a very you don't normally go to this area of your file system, and you don't want to tamper with the files here, but we're just gonna just observe and see what's what's going on in this directory. So you see on my screen, the directory actually changed to this sign, and if you do a print working directory again, it's actually changed to just a root. Cool. What do you, how do we know what sort of files and folders are there in that particular directory? So we can actually conjure up, or we can actually use this command called ls, short for list. And if you type ls and enter, you can see a range of characters that represents either folders or exact files from that particular directory you're working on. Okay, on my system, it does color code folders and files separately. So light blue is actually folders, and then the cyan are actually files. On your system, you may or may not have this color coding, but it doesn't really matter. It's actually nice to have, but it's not always there by default. By the way, you can actually change the aesthetic of your terminal if you go into preferences on your Mac. I don't think Windows have it. You need to have a different preference section. But on Mac, you can actually configure and use a dark theme or light theme, change the font size and all. We can actually provide flags or additional arguments to functions. So for example, if I were to type ls with a hyphen, and immediately following that the character L, so it's -L, we can actually convert this to a slightly more descriptive view of the folders and files in this directory. We have slightly more information, which includes I think this is the date that it's being created. April, yeah, I created this about April. So yeah, this is the date that the folders and the files are made. Then it also tells you who have access to these files and folders. So currently I'm in root, so the root system has the main access. So if you do not have permission, you cannot really use the files and move folders around, which is a good thing because you don't want to tamper with these files to begin with. And then this very cryptic, sort of array of letters basically tells you the permission that each of the users and groups have on these files. So some of them, some of the files can be accessed by other users. Some of them can't. So like this is a very specific folder just for the root user or the administrator, if you want to put it like that. So how do you know what sort of flags are available for that particular function? For example, if I were to use ls with an lh, the h actually tells you a different function or a different argument. So if I press enter, it does give me an additional information on the size of the file and the folder that contains in this directory. So how do you know what the command is and what sort of arguments that it comes with? On the Mac and on my computer, there is this function called man, which is short for manual, that tells you exactly what's the description of these functions. On Windows, sadly, I tried this. You can try this on your own, but I believe it doesn't have this function man somehow on Git Bash, but it's okay. I'll give you another alternative. So if you type man followed by ls, the function that you're trying to run, it will give you this this sort of like page with all arguments and the description of the arguments that you can actually read through and have an idea of what you can actually do with the function. ls is a very simple function, so it's actually quite straightforward. You don't really have to temper around with all of these arguments, but you may have other functions which are a little more difficult to use, so which might be useful. So you can actually use your cursor to your mouse scroll to kind of scroll down, and if you're happy, or if you're done reading this, you can press Q. I'm going to press Q on my keyboard to exit from the manual. Okay. There's another way to actually print out some sort of help. So for Windows user, you can try this out, which is ls, and then with a double dash, type help. This is quite universal, so most functions. Sorry, yes.
Can you scroll down? I can't see the bottom of the.
Oh, you can't. Okay, so let me see. I'll show you in a bit how to clear the screen in a while.
Okay.
So I'm having this. I'm gonna show you again. What I did was to type ls, the function, and then double hyphen and help.
I can't see the typing.
You can't? Okay, so I'm okay. So maybe I'll tell you exactly how to clear the screen. So if your screen is cluttered and you want to kind of like clear whatever is on top, the function is called clear. So so now you see my screen is being cleared. So you can type this on your own computer as well. I'm going to type this again for those who can't see the previous function. Since it's so far down, it's clear, and it will clear everything that you have in your screen. It will not clear the history, don't worry. Your history are still safe. Just that it clears the view of your terminal at the current moment. Okay, so as I was saying, the help, another help function that you can actually invoke is ls followed by double dash with help, and if I press enter, it does print out some form of it's not the same description as in manual, but it does give you some form of help guidelines on the function. I'm going to clear the screen again. This is quite a big chunk of text. Cool. We can also provide other directories, so we don't really need to list files in the current working directory. We can point or specify other directories to list the containing files and folder. So for example, so now I'm going to list down the files I have in root again, and you can see that there are a couple of folders here. You have bin, which actually contains all the codes and binaries that execute. Even ls is actually a code or a script within bin. I'm going to try out, I'm going to try to list out the files in dev. So this is a developer folder. A lot of developers actually play around with this particular directory to configure your boot up, or configure the preset settings for your computer. So I can type ls with a -l and then type dev, which is actually a folder within this directory. So this will print out another long list of files and some folders, and you can see it is quite a handful of files in this dev directory. Okay, I'm going to clear this screen again. I'm going to clear this screen just to make sure that it doesn't get too cluttered. You can also, specify other directories, not only within your current working directory. For example, earlier on I told you that this sign tilde, I'm not sure if you're able to locate tilde on your keyboard, but it's usually top left hand corner of the UK style keyboard. So if you type this, it will list out the folders and directory in your home folder, the folder that you actually open up the terminal from. So on my computer, I see this list of folders and file in home. I'm pretty sure on Mac you should see very similar file system. On Windows it might be a little bit different, but you get the idea of listing folders somewhere more distant as compared to your working directory. sometimes you may run into a problem of identifying where exactly or what's the path for certain direction. For example, you have a thumb drive, or you have a hard drive, and you want to do some sort of manipulation in bash, and you don't know exactly what's the path to that particular drive. So I'm going to show you a couple of ways to retrieve that. It may be different for different system. I'm going to show you the first way. I'm going to stop sharing just the screen because I have to show the entire screen to bring up my Windows or my file system. Apologies if you see my script here, because this is exactly how I carry out this workshop. I have a script on one side and then terminal on the other side. I'm gonna open up my we call this Nautilus on Ubuntu, but on the Mac it's a Finder. On a Windows it's File Explorer. So for example, I want to do an ls. Again, I like the -l argument because it lists out in a much more nicer form. You can drag and drop folders into your terminal. So if I were to look at, let me see, which folder should I show you? I think it should be fine. It shouldn't have anything weird in there. So I'm going to drag and drop and put it into terminal, and you can see that immediately it prints out the path to that directory, GitHub_repo, and then you can actually press enter and list out what sort of files you have in there. You can do this on Mac, I'm very sure of that. On Windows, I don't think you can drag and drop, but there is an alternative. If you open up your File Explorer and there is a folder that you wish to sort of paste into terminal, you can press, if I'm not mistaken, hold on Shift and right click. There is this option that says copy path. So you want to see something like copy path file or path name, because path tells you the entire directory or the entire address of the particular file or folder. If you just copy the file, it will not give you the entire path. That's the only small caveat. On the Mac, I think you can press Option and do right click as well, and you have the option to copy path using the right click method. But if not, you can drag and drop, and that drag and drop works perfectly fine on the Mac. And then pasting on Windows, you can't do Control-V, which is a little bit weird. You might want to do a right click on the window, and right click immediately will paste whatever that is on your clipboard into your Git Bash window. So give it a try. It's not completely necessary. Sometimes you might be able to locate your files much more easily than this. So don't worry if you can't figure out how to copy this. Cool. I'm going to move on and move to the next section, which is a activity. I think this is quite fun. So do head over to Etherpad. I'm going to share my screen first. Do head over to Etherpad. I'm going to paste the activity questions. So we're going to paste almost everything here so that you have an idea of the code that I have done up so far. So look at activity 1, and I want you to give it a try to list out the files in 3 different. Actually, sorry. Before that. Sorry, my apologies. There's one thing that I missed. So if you go back to your terminal or your Git Bash right now, there's one thing that is actually quite cool, which is to list out certain files based on a pattern. For example, if you have a folder that has tons and tons of files, and you don't want to print out, you don't want to view all file types or file names, there is a way to just select certain file, and we call this using wildcards. So I'm going to show you how we do it on the current root directory that we're in. So if you try ls-l, and then we're going to look at the directory bin, right? And I'm going to just print out all the files and folders that begin with letter B. Okay, so the way we do it is to type bin with a forward slash, and then type B and an asterisk. So it should look like this. Again, I'm going to I already pasted it on Etherpad, so if you can't follow this, there's the function you should do that on Etherpad. And when I press enter, it will list out a smaller list of file or folder that starts with B. And this is, again, very useful if you know that you want to look at certain file. For example, you want to look at text file. You can actually change this wildcard a little bit. So what does this mean is that figure out or print out file that begin with B, and it doesn't matter what precedes the letter B, print out anything as long as it starts with B. If you want to do it the other way, to print out, let's say, a file that ends with B, you will start with the asterisk and then type B. So the file here, that it will start with any character, any sort of like alphanumeric character, but then it has to end with B. I don't know if this will return anything. It does. So it does return 2 files on my computer that ends with B. Okay, so with that, then you can actually now do the activity. Yes.
I'm getting an illegal option command.
For which particular?
I tried ls lbin /a asterisk.
Yep.
And I'm getting illegal option.
And did you do ls with a -l as well?
ls -lbin.
Yes.
/a asterisk.
And you're still getting that. Did anybody also have that illegal message coming up? Okay. I'll message you personally, Ali, and then I'll see, because we have an activity, so we can go ahead with that.
Yeah, sure.
All right. So yes, just try this out. So basically, look at another directory which is slightly more deeper in root, and print out these 3 sets of list of files in activity 1. Okay, just take about 2 minutes. It's not going to be too difficult. Okay, so how do we do this on our own terminal? So function is ls-l, and we're gonna use the user/bin and call out anything that starts with letter C. So this is the same as what we did previously, C followed by an asterisk. So we have this. Mine is quite a lot. Hopefully yours is not too bad. I'm going to clear the screen first before I print out the next function, ls, and then the second command ends with letter A. We also already showed this earlier on. So it's asterisk followed by an A. So this is not too bad. And then the last one is a little bit tricky, because you want no, sorry, the second one is not big N with letter A, it's contain letter A. So A can be anywhere in the name of the file. So you have to put an asterisk in between the A. So asterisk A and an asterisk. So this picks up a little bit more files and a bit more lenient with your file search. So all of these files should have an A somewhere in the name. And then the last function is one where we call out files, user, bin, and then ends with an O. Okay, so if you are have a file with A in bin, so I see. So sometimes you might get a you might get some error. So Ali is getting this error that says no such file or directory. Sometimes it might be due to that you don't have files that begin with A. But if you do have this file somewhere, do try with other letters and see if other letters works fine, because sometimes it's just a matter of naming of the files. So Ali, give that another try.
I tried everything. I mean, I tried A, B, C, T, F, everything.
Can you print your directory for me? Can you do PWD for me? PWD?
Yeah.
Can you print that for me? PWD and paste it in
It's,
chat.
it's a users/Alibora.
So yeah, you where we are right now, you need to be in root. So
Okay.
do a CD,
Yeah.
and with a front
Forward.
slash. So we are currently in root directory.
Okay.
So and the reason is because in your home directory where you are earlier on, there is no file or folder called bin. So you need to have, based on the code that we actually typed earlier on, the bin folder has to be in your working directory. Okay, so we're still in root. It's okay. It's we're not too far behind.
Okay. Thank you.
Cool. There's something that I want to actually mention about. I'm not sure if you noticed this. If you press on your up arrow key, you can actually call out previous function that you actually type. So I'm going to type 1, press on up arrow once, you're going to see clear. Twice, I'm going to see all the other functions that I have actually used before. So it's like a history of your functions one by one. So it might be convenient to sort of reuse your previous function and then just amend the code to search for files in different directory. It's actually much faster rather than typing out the whole thing over and over again. Okay, there's something quite interesting there. Okay, so we're gonna move back to a different directory. So we're gonna get out of root. Not gonna stay too long in here. We're gonna change directory to desktop. And I checked this. All different operating systems should be able to do this. So the function to change directory is cd, followed by a tilde, and a / desktop. Give this a try. And you should now see that your working directory has changed to desktop. You can do PWD if you want, and it should say something like users, your name, and then your desktop. Okay, so I can print out my desktop. My desktop is not, there's nothing there. I don't usually keep stuff in my desktop, but you might have some other files and folders there. It's fine. If you if you were to do a CD to a directory that doesn't exist, so because my desktop is clean and there's no other directory, there's no other folder here. If I do a CD of, let's say, downloads, it's just an arbitrary name, an arbitrary folder, it was gonna print out the same exact error that Ali actually pointed out previously, which is no such file or directory, because there isn't downloads in my desktop folder. You can try this on your own and see if this works. You can also move up one directory higher, or move up to a parent directory. So now instead of desktop, I'm going to go back to home, which is the tilde sign that I showed you previously. And you can actually quickly, using a shortcut to go back to home by typing double period. So it's 2 period. And this goes back to home. So this tells you that you're going back up one directory. And it has to be relative to the directory that you're in. So if your directory doesn't, if you're in root, for example, your deepest layer file system, if you do CD with a double period, you will not go anywhere because you're already in the deepest layer of your file system. Okay, so this is relative system. So just to reiterate, a full path. So if you want to specify a full path, I'm going to retrieve back this function here, cd tilde desktop. So this is what a full path looks like. I can also do the same thing and change to downloads. And because I specify the tilde with / downloads, this is giving a full path of downloads. This is successful because downloads, I'm not saying that downloads is in desktop, I'm saying that go back to home and go to the directory downloads. So I hope this makes sense to you, to specify the full path of your directory. And then I can also go back to desktop again using a relative directory. So instead of tilde, I can also do double period, which will go back to home, and then followed by desktop. Sorry, typo, desktop. Okay, it will do, this is successful because it's going to go back up one directory and then go into desktop, which is in the home directory. So this is fine. Questions about this? It's not very important. It's not like very big thing, but it's nice to know that you are able to actually change directory not only by specifying the full path, but also relative path from where you are. Because a lot of time you're dealing with a working directory, and it's easier to remember where exactly your files are relative to your working directory. Okay, let's try this out with an activity. So I'm going to paste the code as well as the activity into Etherpad right now. So activity 2, do click on the link. I'll share my screen as well so that you can see the question. It's going to be yep, here. Okay, so basically there is this a question. I took this from the Data Carpentry's website. So you have this file system. It looks very similar to your home directory. And you are currently, based on the question, you are currently, if you print pwd, you are currently in users /thing. So you're here. What would be the output of ls double period and backup? What do you see as an output when you type this into into your terminal? You can't really do this. You just have to you can do this on your terminal because you don't have the same exact file system. So from this image here, figure out whether is it 1, 2, 3, or 4. So to answer the question, I'll suggest you to type a 1 on one of the 4 options that you think the answer is. Okay, so I'll give you about 2 minutes. Shouldn't take too long. 2 minutes. I'm gonna off my sharing screen. Can have a look at the link on Etherpad for the question again. Okay, I think we have several inputs. At this moment, I'm gonna share my screen. I apologize if when I'm sharing screen and suddenly Zoom goes to full page, full screen, and then you have to click close full screen. It happens to me all the time and I get annoyed. So I have to apologize first if it happens. So we do have two major answers, 1 and 4. So let's go through the question and see what the answer is. So ls lists out the files that you have or folders that you have in a particular directory. And because we're specifying double period followed by / backup, we are using a relative path to where we are. So we are currently here, users thing. If you can see my cursor, typing double period and backup will bring you up one directory. So you're going to be back in users and then down in backup. So this is a legit directory because there is number one, you do go back up to users, there is a parent directory, and also there is another directory called backup in users. So this directory here, this path here is actually a correct path. And then ls will print out the folders or files in backup. So we're going to print out the names of these three folders. So one should not be an answer because there is indeed a directory called --/backup because it exists here. And answer is 4 because it prints out the name of these three folders in backup. Okay, I hope you get that, and we can move on. Cool. Next part is quite interesting. We can now make things. So on your Windows Explorer or on your terminal, you're able to right-click and create a new folder. You can create new file using text editor and stuff. So we're gonna do exactly that in terminal. Right, clear screen first. So we're going to start with making folders and subfolders. The function to create folders is called mkdir. So the name seems to be very intuitive. This is short for make. Mk is make, dir is directory. So you're making a directory, and you can specify any name that you want. All right. I'm going to use test underscore folder. Again, we're still currently in desktop. It's fine. We stay in desktop. There's a reason for that. And I'm going to press enter. And you can on your computer see that desktop now creates a new folder. I'm going to do ls and show you that instead of having an empty desktop, now I'm cluttered with one folder called test folder. Okay, we can create more than one. We can rinse and repeat. I'm going to press up arrow on the mkdir make directory function, and I'm going to create another folder with an 2 right at the back. So now 2 folders in the desktop directory. You can create subfolders. So within any of these folders, you can create another folder within this folder. And you do that by, again, the way you specify path, you specify the name of the new folder that you want to create, followed by or preceding a /. So inside test folder, I'm going to use this test folder. I want to create a new folder within this test folder, and I will name it subfolder. So again, what does this mean? Within test underscore folder, create a new directory called subfolder. And I'm going to press enter. And I'm going to ls test folder. I'm not going to ls the working directory. I'm going to ls test folder. And you can see that subfolder is created. Okay. Again, very convenient, especially when you have a script and you want to create multiple folders, repeatedly. You can do this very quickly. As you can see, I like to use underscores. I like to use, I do not have spacing in my folder names or even my file names. I do keep a continuous folder names with a hyphen or underscore. And the reason because it's easier for you to type out names of files and folder with a full name. But sometimes I understand that you want to create a folder with a space, you know, so to kind of like make it neater. To do that, you have to actually type out the name of your directory within inverted commas. So this is assuming that you are creating or inputting a string or character. So I'm going to show you how to create that within test folder. So let me see, I should put this back again. I'm going to create the open inverted commas first, test_folder, and then create a, my keyboard is sleeping, give me a minute. Okay, it's here. And then sub, and then space, and then folder with a space and 2. So the subfolder will be will have a space in its name, and this should no, sorry, it's not ls. We're not trying to ls here. We're trying to make directory. So mkdir and create. Okay. So if you're gonna ls test folder, this will show you 2 folders. One folder called subfolder, the other one has a name with space in it. Okay, I personally would like to advocate you, if you're doing this more rigorously, to create file names without space, because it's you sometimes forget which files have space and which files do not have space. So you either have to put hyphen for everything or do not put hyphen for all of these functions. Okay. So I'm going to paste this set of code into Etherpad if you want to follow through and want to copy and paste. What about text files? I'm going to clear this screen. You can also create text files, or just a simple files with some text in it. So instead of make directory, the function is called touch, touch, and the name of the file that you're going to create. So I'm just going to put simply test file.txt. Okay, and you can see now in my desktop, I have another file called test_file.txt. Okay, I'm going to create a couple more. I'm going to create maybe 2 more with a different naming, and then with this. So three files, and then a couple of folders in my desktop. If you were to create or touch a file name with a name which is already pre-existing, so you accidentally type something, don't worry, it will not overwrite your previous file. It will not clear your previous file. It will assume that that you're trying to make a file which is already there. So you don't worry about overwriting files. We can let me see. I'm going to show you how to copy files first. Okay, so let's say we have this test_file.txt, and we want to move this, we want to copy this into one of these folder. All right, and the function to copy is cp, right? Cp is for copy, and the argument is number 1, the file or folder that you want to move or copy, and then followed by the destination folder. So first input will be test, let's say file.txt, and I'm going to put this into test_folder. Okay, enter. If there's no error, there's no other message coming up, means you're successful. Just show you with an ls of test folder now, that test_file.txt has already been copied into that particular directory. Okay. What about moving? What about moving files? You can also do the same thing. Instead of copying, you're going to move the one of these text files. Actually, I'm going to move more than one. I'm going to move all the text file from desktop into the subfolder. All right. And if you remember, we used wildcard previously to select certain files that has similar, file names or start with certain characters. So I'm gonna show you how to do that. So moving, the function is called mv move. Again, it's nice and short. That's why I like it. It's very simple and very short. So move, and again, the argument is the same. You're gonna move certain number of files and then put it into a destination folder. I'm going to select sris.txt, so all .txt file in desktop, so all 3 files here, and I'm going to move it into a slightly more deeper layer, so test_folder, and then put it into subfolder. Okay, so essentially taking all 3 text files and putting into subfolder directory, which is slightly one level down. And you can see in ls on desktop, all the txt file are gone. And if I go to ls, the subfolder, test_folder, subfolder, you're going to see that all the test files are there. Okay, cool. What about editing this file? Can you edit these files directly in terminal? Yes, you can. It's actually quite cool, actually. So I'm going to cd into test folder, which has one of the folder that we copied. It's empty. It's exactly it's an empty text file, and we're going to edit this file in here. And the function or the sort of, this is more like a software. It's very small, very very handy software to actually edit things. It's called Nano, and I checked this on Windows. If you follow the instructions that I provided you step by step, you should have Nano on Git Bash. So you type Nano followed by the name of that file. A quick tip: if you have a file name which is extremely long and you can't or you don't want to kind of type the whole thing, you can actually autocomplete your file names. And autocomplete basically means that the terminal will figure out what exactly you are trying to type, what files are you trying to call, and if there's a unique file with that name, it will autocomplete the name. So if you press tab, I'm going to press tab right now, and you're going to see that it autocompletes to the name of the only file that starts with test. So a very shortcut to doing these sort of operations. So press enter, it will bring up a new a clear screen that starts with GNU Nano. So this is a proprietary software that deals with text editing. So then we can type whatever we want to type. So this is a test readme file. I'm going to just simply put or label some line 2, 3, 4, 5, line 5. You don't have to follow me. So this is just for illustration. Line. I'm going to put one more line. Probably this is 20, probably. Okay. So you can type it anything you want. You can document certain functions if you wish. Later I'm going to show you how to actually automatically save some text immediately into this file in a simpler way. Okay. And then to exit this, you can save. So on the bottom of the screen, I hope you can see that. I'm gonna, for this purpose, I'm gonna pull up a little bit so you can see the options here. There is there's a couple of stuff here. One that didn't specify is actually saving. You can press Ctrl S. Even on a Mac, I think Ctrl S works. So if not, try Command S. You can try Ctrl S, and it will give you this message that says it wrote 24 lines, which means that the document has already been saved. Right? Try Command S or Ctrl S on the Mac. I know on the Windows it's Ctrl S for sure. And then to exit from Nano, you can press Ctrl X. I'm going to try Ctrl X, and it's going to bring me back to my terminal as such. Okay, I'm going to paste this set of code into the Etherpad if you want to follow through. Okay, and clear the screen to show you the next section. Okay. So then once your file contains some sort of content, some sort of information, you can preview or view the file in terminal. To view the entire file, the function is called cat. I still can't figure out why exactly it's called cat, but I think it's concatenate or basically stitch things together, if I'm not mistaken. But function is called cat followed by the name of the file. So it's test_file. I'm going to auto-complete this, and you can see that all 20 lines, or each 24 lines, are printed. And then you can also preview certain lines. So instead of the entire 20 lines, 24 lines, you can preview the first 10 lines using the function head. I think those who have been in the R workshop, you are familiar with head. It's more simpler now because you don't have to have brackets after the function, just head followed by the name of the file, and it prints out by default the first 10 lines of the document. Okay, you can change the number of lines to print. So I'm going to press up and then move back my my cursor, this typing prompt to somewhere here, and I'm going to type /n and then 4. Basically tells you that the number of lines to print is 4, and you can actually control the amount of information to actually print out. And this is useful because you might have a document with like thousands of lines, and you don't want to, clutter your terminal with thousands of lines. You can do so. It will not, run into memory problem because this whole terminal thing is it uses very minimal memory, and it deals with very simple files. So you can print out, but it can take quite a while if you have a lot of stuff in there. Okay, I'm going to clear the screen again, and we're going to go through the last part. It's a very small, very useful part before we go for a break. We will have a break. It's not fair if I don't give you a break, and it's also good for learning to have a short rest. So last part, which is to delete files and folder. This is, be very careful. In terminal, it's not like on Windows or Finder. You can't, not that I know of, undo anything removed. And it's not going to be in your rubbish bin or in your recycling bin. It's going to straight be removed from your file system, because you're dealing with terminal. You have to be very careful what you delete. Okay. Function is rm, to remove, and followed by the name of the file that you are trying to delete. So I'm going to delete exactly the text file that we just created. And I'm going to press enter. And then you can see that in ls, the test file is no longer there, and it's no longer found even in my recycling bin. Okay. You can also delete directories, an entire directory. And the only difference is that you have to specify one flag. So I'm going to delete this entire test folder that we created. I know it's a bit redundant to kind of like create and then delete, but it's a kind of a fun thing about being able to do things, where you can make and break things. We're going to remove the entire folder, but we are going to specify a flag called -r, and it's short for recursive. It basically means do this function again and again until you reach the end, or when you have nothing else to delete. And we're going to delete the folder test_folder, right? Right, you ready? I'm going to press enter, and the entire test folder is no longer there, including its subdirectory, including all the files that we have moved and copied and paste, whatever. Everything is gone. Okay. Again, useful to clear your file system in a bit, but be very careful with this function. Cool. Time is 11:20. I'm going to give 10 minutes break, but at the same time, I'm going to have a short activity. So feel free to go for your break, or even do activity. It's not going to be around 2 minutes activity. I'll paste the activity and all the other code that I have in Etherpad, so you can have a look at Etherpad. So basically, I just want you to go back to your home folder and create several folders there using terminal. And I trust that you do practice and try out this creating directory from terminal. There are several folders that you are going to create. I will explain to you what these folders are, but just pay attention that within the folder originals, I want you to create a subfolder called FASTQ, and we will pick up from where we stop after the break. So about 10 minutes, we're going to come back half an hour past 11, right? Cool. So if you haven't tried the activity, the answer is in Etherpad. You can copy that and paste it into your terminal if you haven't done so. If you haven't made it, if you made it, that's fine. If you have the idea of how to create a directory from terminal, it's a good start. So the reason why, so I'm going to show my Etherpad screen and then move on from there. So the reason why I told you to create these few folders is because this is one of the way to manage RNA-seq experiment. There are different ways, but this is sort of the most consensus way. I think people adopt this more frequently. Basically have a parent directory that contains the project itself. So I'm going to call it RNA-seq workshop. And then within it have a folder called log to log all your operation, like what functions that you run, what script that you run, metadata containing a list of the files or the RNA-seq data, like what are the data, where they're coming from. And original store all the original files that you downloaded or retrieved either from your sequencing facility, or if you downloaded a data from somewhere else, it's nice to put it into originals, and then have another folder called output that processes these files to create output files. So separate the originals from each other, originals from the outputs to sort of manage your directory a little bit. And then the last is scripts, or I call it readmes, because it allows me to kind of like look at your code, whatever you run, and see how is it perform. You can modify your script as and when you want. Okay, so make sure that you have this directory already there, because we're going to use it today, and also for in 2 weeks time we're going to use the scripts a bit more frequent 2 weeks time. So let's move on up a notch. We have another half an hour. I should be able to finish in half an hour, but if not, I might bleed in just a little bit, not too long, so we don't have too much after this. We're going to move into RNA-seq as proper right now, and tell you that there are 2 popular repositories that store RNA-seq data. One of it comes from the NCBI. And somebody just erase. Why did you erase? No, I'm just joking. I'm going to paste this again. So back on Etherpad, there's 2 repository with links to the repository. One of it is NCBI. This is called GEO. A lot of times, if you look at the publication and they store RNA-seq data, they will specify the GEO session. This is exactly where the data is stored. You also have the EBI or UMBL repository. It's called ENA. I personally prefer GEO, but for this demonstration, I'm going to go with ENA. I'm going to tell you why in a bit. So if you can go to ENA, you just click on the link. It should bring you up to ENA, and you have the option of searching for projects or certain, fields that you want. For example, you want to search for a single cell RNA-seq, you can search for that, type in your favorite protein, for example, and it will come up with hits that correspond to your query. I'm going to type this project called, let me copy this project. Yep, I'm going to type this project. If you can type, you can paste it with me. I'm going to paste into accession. So it's PRJNA476008. I'm going to paste this into Etherpad, don't worry. So in Etherpad, you can copy and paste the project that we are going to look at, and click on view. And you can see a description of this project for where it's coming from, when was it created, as well as all the sequencing files that were associated with this project. So for your information, this is data from the Allen Brain Institute, where they have sequenced mouse neocortex from 2 different regions, the visual cortex and the lateral, anterior lateral motor cortex. And they did single-cell RNA-seq, and these files here represent each of the sequencing from the individual's cell, or single cell. And again, you can do this for any experiment. You can search your experiment. I found out that even if the let's say you go to publication and it specifies a geo accession, you might be able to get the data off from ENA. Somehow they do keep data from all different publications into both repository redundantly. So I guess that's good. So we can play around with this to repository. But the reason why I'm showing you ENA today, because it's easier to download using terminal or to retrieve the FASTQ files as compared to using geo. Okay. And because this is a single-cell RNA-seq experiment, each data or each file is actually very small. It's about 100 megabyte after compression. So it's not going to blow up your file size, your hard drive or whatever. If it's a bulk RNA-seq or full RNA-seq experiment, it might take up a couple of gigabytes. So be wary of the file size that you are trying to deal with, and make sure that you have enough storage to hold all these files. So we are going to go ahead and download the first 2 files. All right. I can't remember, I don't think you mentioned which cells it come from, but it's coming from one of the cells in this experiment. I'm going to show you the easiest way to download this file using terminal. You can click on this, left click, and then follow the the instruction to download this file somewhere. But because we are doing command line, I'm going to show you how to do it on the command line. So go ahead and right click this and copy the link. I think make sure you copy the link and not the text itself. So copy the link, all right? And I'm going to switch back to the terminal. So make sure it's still on clipboard and you don't over copy other text, right? So I'm going to bring up my terminal, not this terminal. Okay. And the function, the command that we're going to use to download this file is called curl. There is actually 2 functions. I'm going to use curl today. I will give you the other function in the Etherpad later on. And
Farsham,
yes, Benedict,
can you just show me, because I got a little bit slow. Could you show me again how to copy those files?
Yeah. So okay. Do you see the? Okay, I'll show you again on the page. Don't worry. And share on here. Okay. So I was saying, so if you look at this column here that says FASTQ FTP, all right, you see 2 files. Maybe I didn't mention this. The reason why there are 2 files is because this is a paired end sequencing, which means that for every sequence, for every RNA, the RNA is sequenced both in the forward strand and in the reverse strand. So you do have a certain bit of sequence being sequenced on both ends. All right, cool. So you right click on this and copy the link. Okay, cool. So as mentioned, the function is called curl. So if you type in curl in terminal, let me bring up this first. Okay, so it's called curl. I'm gonna make you to get you to input one flag, which is dash with a capital O. It's capital O, followed by the link. So Mac, again, command V should be fine. It pastes the entire link. Windows, do a right click. That should paste the link directly into Git Bash. Should be no problem. Okay, dash O.
Sorry. After the capital O, what do I have to do?
So paste the link that you have copied from the ENA website.
I do this how?
Say it again.
How do I do this?
Yes. So right click. So you're on Windows, right? So
yes.
Right click in the terminal or in the Git Bash window.
Yes,
then
it worked.
It works.
Thank
That's
you.
good.
Yeah.
No worries, no worries. Yeah, I honestly I tested this on 3 different operating systems, so I'm very sure that it will work. Cool. So the reason why I asked you to do a dash capital O is because this will save it into the directory that you want. Actually, before that, I'm in the wrong directory. This is a mistake, but it's okay. And then it will reuse the file name that the repository have actually assigned. So the SRR73 and so on and so forth will be reused. So you do have the option to change the name, but in this case, let's not do that and just stick. So just press enter. I know I am currently in, you can do this, it will take some time, not too long, maybe like about a minute. I'm currently in home directory. I shouldn't be here. I meant to actually, go into the FASTQ directory, but if you've done this, it's fine. We will copy the file that you have into the FASTQ directory in a bit, and then we'll basically show you, we do this together. So as mentioned, you sometimes will get paired end sequencing data, as you can see here. Sometimes you get single end sequencing. It doesn't really matter. Of course, paired end is slightly better because you have more information, you have more reads coming from your experiment. That means that you can have better coverage or better depth of your sequencing. It is taking a bit slow today. Hopefully you're done, or hopefully you're not having too much of a problem.
Mine says it's going to take 20 minutes.
No, okay, that's not good.
I have some major errors in my terminal.
What does it say?
My terminal is beeping at me, and it has become a huge array of question marks and random letters.
Can you share your screen and have a look?
It's on mine. Is that
let me see. Let me see.
Yeah, okay. Sure.
Yep. Okay, can you stop? Okay, can you press Control Z?
Okay.
Okay, so I haven't. So you made an error. It's a flag. So -O. Instead of a, I think you put a tilde O. Tilde O will to do a dash O. You might need to use your cursor to kind of like back up a little bit. Do a -O. Again, the difference is a flag begins with a dash or a hyphen. While that now should work better.
There we go. Thank you.
Yep, no worries. Whereby tilde is specifically a shortcut for home directory. So that should be an error in terms of, it shouldn't be interpreted at all. But if it does, then might be some bug in the code. Okay, so give this a while. It's okay. I'll give you some time. Even if not, just do in the background. Again, I'll paste the code as we go along, and then you can pick up from where you are. Even mine, it took quite a while. So next session, I'll get you to download this before the class, so we have the files already for the class. Okay, we can go on and download the other read pair by doing the same thing, but I'm not going to do that just to save time. So I'm going to just deal with just one FASTQ file right now, and I'll do this slow, so give a bit of time to for others. Okay, so as you can see, it's currently in home directory. I don't really want it in home directory, so I'm going to move, and then the name of the file is SRR. I'm going to autocomplete it and put it in the directory I created earlier on, which is RNAseq _ workshop. I'm going to autocomplete into originals, autocomplete, and FASTQ, autocomplete, and with capital A, because it's capital A like this.
How do you do the autocomplete?
Yeah.
So you press tab. So to autocomplete quickly the file names or folder names, after you type a couple characters, you press tab. If the name of that file is unique, it will immediately autocomplete the name. If there is some conflict that let's say several folders with very similar starting names, you might need to type in a little bit more and then autocomplete it.
Is that the same for Mac or?
Yes, it goes again for Mac and Windows for all terminal. It works. Okay.
Doesn't seem to work. Tab.
No.
Tab. So I type in SRR tab. It should autocomplete, but it doesn't.
The button above caps lock is. Do you have that working on your keyboard?
Sorry, yeah, I got it now.
Yeah, is it fine?
Yeah, all good. Thank you.
Cool. So I'm going to do this and show you that my home folder should not have this SRR, and I'm going to CD directly into RNAseq originals and FASTQ originals and FASTQ. And then in FASTQ, you will see that one file, one FASTQ file. Okay, I'm going to paste this set of code so that you can follow along in Etherpad if you're having problems so in there it's already CD'd into FASTQ first, followed by the downloading, so it's a bit more easier. I made a mistake, so now we rectify the problem. Okay, cool. It's currently compressed. It's a GZ compression. We can unzip the file using a function called gunzip. You can try this out with me if you have the file already installed, already downloaded into FASTQ. So gunzip followed by the name of the file, again, autocomplete, very convenient. It's not going to take too long. It will then convert from a fastq.gz into just a FASTQ file. And the reason why we are unzipping today is because we want to inspect the files a little bit more. If you don't want to inspect, you're just doing the normal workflow, we don't necessarily need to unzip. We're not going to unzip this in the next 2 weeks. So we usually keep it into a compression file because it saves space and it's easier to deal with. But if you were to preview a compressed file, it's going to print out binary, as what I think Pat saw, because I think it's trying to print out the contents of that file in this very weird symbol. It's all a binary compression. Okay, if you remember, we can use the preview functions called head. So if you do head of this file, we can actually print out the first 10 lines of FASTQ, of the FASTQ file. And then we can also select the first 4 lines, and you can do this with me because the 4 lines are actually what we is enough to sort of go through what we need to go through in the next section. And I'm going to move this up a little bit so you can see we can see the first 4 lines. So every single sequencing sequences in this file is grouped together in blocks of 4 lines. So every 4 lines is one set of sequence, and each line has different meaning to it. So the first line is the name assigned to that particular read, and it has lots of information in it, which includes the accession number, the SSRR ID that it was assigned to, and some information on the lanes, as well as the position on the chip, exactly where it was sequenced from, as well as towards the end, the replicate. So this is the first replicate of this pair-end sequencing. A lot of this information is not, you don't really use so often, apart from the fact that it's a first replicate of this sequence. And if pair-end sequencing, you need to have the pair in the other files, which we didn't download. But you can try it out and download the other files, which I have pasted on Etherpad, and make sure that the namings of both reads are the same. The only difference is that the last number is a 2 instead of 1 because it represents the other read pair. And then this is followed by the sequence, the all familiar sequence that we all know and love. And then a space, which is a plus sign, followed by the quality of the read. So the length of the fourth line is identical to the length of the second line, because each of these bases has been assigned a quality to it. So that there is some sort of a scoring system for the quality. I think if you're familiar with Fred scoring system, this is exactly what a Fred scoring system looks like. I will I need to find the link to the scoring system. I'll paste it in later on. But there are certain ways for you to figure out which base is of low quality and which base is of high quality. Then you can decide how to trim your read to make sure that you are inputting good quality read into downstream tools. Okay. I didn't mention this, but you can also do tail, which actually is the opposite of head. You look at the last few lines, and you look at the tail of the last few lines of this file, and it looks like different. The numbering and the position is slightly different, and you have a different sequence from. It might be useful to use head and tail as when you want to preview. If you want to have a look at the entire file, I would suggest not to do cat. Please don't do cat on the file, because cat will again print out everything into your terminal. I'm going to clear the screen first. I suggest use less. Less is a bit more cleaner, and it gives you this sort of like document style view that you can actually scroll up and down and just preview your files to make sure that everything. Well, one thing that you want to make sure is actually the read pairs between this first read and the second read is sort of in the same order, because most tools actually parse the data in the same order. So the order of the reads have to be more or less similar. I ran into a problem once with data which is not sorted properly, and it crashed the whole entire pipeline, and one day wasted. So you can just pass through, you can screen through, you can type in /n if you want to search for something. Let me see, it's / and then followed by anything that you want to search for. If I want to search for capital N, I think I press enter. No, and enter. Oh, it's not working now. It's not working. Oh, it's crashed. Okay, so what basically that does is to it's basically search for a certain string, and N basically asks if there's any non-call or miscalls in your sequence. But I guess there's a lot of miscalls, and also the name of the file is contains an N, so probably it might take quite a while. But you can actually cancel this. You can go back to terminal if you press Ctrl-Z. So I'm going to throw Ctrl-Z and hopefully it's fine. So I did Ctrl-Z, so it stopped the whole less program. So if you have a problem with, let's say, it prints out endlessly, and you want to get out from that, you can do Ctrl-Z, so like undo and go back to terminal, right? So that's actually quite convenient. So previewing files, again, not always necessary, but it's nice if you want to have a look at how your files look like, because there's so many sequences you cannot figure out exactly what sequence map to that. You need tools to help you map anyway. But then you can do some sort of search or pattern search in terminal. So earlier on, I showed you how to, in a very bad example, how to search for N in less. It takes quite a while because it has to do kind of like a couple of search. But there is another function called grep. And what grep does is it does a search function on your file. So let's say we want to search for, let's see, I'm going to search for an N doublet. So it's going to be a bit more better because it will not conflict with the names of the sequence. So I'm going to search for double N. You can just type it as it is. You don't have to type it in inverted commas, open inverted commas if it's not a separated string. If it's like one whole stretch of string, you can do it like this. this is followed by the name of the file that you input to search your search parameters. So you're going to search for this, and you can see not too big of a list. All the sequences that contains these N doublets. It's not a lot. I did try, you know, inputting, let's say, a couple more N's and search for this, and it does come up with nothing, which is a good sign. It means that the sequencing is good and there's no stretch of miscalls. And if you see stretch of miscalls, it usually means very poor quality read. To begin with, I'm going to clear the screen again. As you can see, the number of lines you print out is there's quite a number of lines, and if you just want to you know, preview some of these lines, you can actually input a head. Those who have been with me in the R workshop have heard about pipe before. So pipe is, again, not a R standard function. It's common to almost all operating system, all coding language. So pipe here, so I'm going to type in pipe and show you. I know that some of you might have problems with pipe, and it looks like this. It's a vertical line. Some of you might find it at the top left hand, UK keyboard is bottom left hand corner, quite close to control. That's where your pipe is. I know of pipe somewhere in the top left hand corner as well. If you're on the US keyboard, it's on the, well, mine is on the right hand side. I'm sorry, Benedict, I don't know, I'm not familiar with German. I think we figured this out. The German keyboard, I think it's somewhere, I can't remember exactly where, but it's somewhere there. Okay, so this is pipe, and then you followed by head, which is the function that we want to you know, perform after grabbing, after searching for this pattern. I'm gonna just search for N doublet here, so that we know that we're gonna get some output, and head will print out just 10 output of this file. Okay. Let me see, I'll paste a little bit here and there on Etherpad. Couldn't gunzip. Okay, and then let's, cool. We can also do some sort of counting of the number of lines or the number of characters in this you know, grabbed output or pattern matched output. One of it is word count. It's WC, word short for word count, and there are several flags. I'm going to use the L flag, so hyphen followed by L. This counts only the lines in this output and not characters. You can specify characters using different flags. I'm going to count the line because it's going to be more useful, because usually sequences are based on line by line basis, and then it prints out that there are 112 lines or 112 sequences with N doublets in there. So this is quite interesting. You can also let me see. You can also save this information somewhere else. So let's say you want to create a new text file. By default, just create a new text file and save the sequences which has the N doublet. Okay, so I'm going to again press up arrow and then just bring up this function here. And I want to, instead of outputting the all these sequences that contains N doublets into terminal, I'm going to output into a file, and I'm going to name it ends.txt. So the way you input is using this bigger than sign followed by the name of the file that you create. And currently we are in FASTQ directory, so it's going to save in FASTQ directory. If you specify a full path or a relative path, it will save somewhere else in a different directory. So we have done this previously, so you can play around with where exactly you want to save. I'm going to do this, and then it doesn't output anything because we have sort of like redirect the output to a file instead of the terminal. And if you were to let's do a head of ends.txt, the head of the file that we created, the sequences are there. Okay. One cool trick is that you can actually control the number of lines to print. So if there is a match to a particular sequence, you can print a number of preceding and following lines of the sequence, which is quite cool because then you can not only print the sequence, but also the ID of the sequence, as well as the quality of the sequence, because then you are able to assess which file or which sequences are bad, and you can do something about it. And the flag to sort of modify this is there are two flags, one for before, and this is -b, and you specify the number of lines you want, so -b1 without any spacing, so -b1. And then to specify the following number of lines, you type -a2. I'm going to use 2 because after the sequence there are a plus sign and a quality sign. So -b1 and -a2 right before specifying the pattern to search for. And I'm going to save this into ans.txt. And you can see that it will override. This is it will override the previous information, and but now head ans.txt has slightly more information of sequence IDs as well as qualities. Now, just a small fact: if you don't wish to override, you wish to sort of like append or add information to an existing file, instead of just using one bigger than sign, use 2 bigger than sign, then you will add on to the information of ans.txt. I'm not going to do this right now. Don't want to add too much information to that file. Okay. That's a very cool activity. But it's about 12 right now. I'm almost done. I just want to show you a bit of preview about next 2 weeks class. But this is a very cool activity. I like it because it's quite interesting. It gives you an idea of what grep can do. But I want to have an idea of whether do you want to do this activity or do you want to practice it at home on free time. So if you want to do it right now, give a thumbs up. And if you want to do it later on your own, give a thumbs down or a cross sign, and I have a feel of what do you prefer to do. Again, there's no obligation. If you have any other work that you want to do right now, you can go and do so. I can apologize for starting the class late, we'll do this on time, make sure that the Zoom meetings are fine next week. So Hannah and Maria, that's okay, no worries. I will again paste all the answers and all in Etherpad, so do refer to Etherpad. I'm going to put this Etherpad for the next 2 weeks, so just go ahead and look at it. I think the rest, I will get you to do this very short activity. It's like 2 to 5 minutes activity. And then we can sort of close this class with a bit of overview about RNAseq. Okay. So pasting the activity right now on Etherpad, search pattern as well. So using the information or the knowledge about grep, I want you to do 2 things and save the output of this operation into a text file. You can name the text file whatever you want, but basically, 1, count the number of sequences in the FASTA file, and I don't mean the number of lines in the whole. So I'm referring to the number of sequences that has been sequenced in this RNAseq file, and then also count the number of sequences that contains this adapter sequence that I've pasted there in Etherpad. So this is a very common adapter sequence that we or a lot of platforms use, because libraries actually use different kit, and Illumina kit is very popular. And then sometimes, depending on the size of your read, you might sequence excess of your read of your sequence that you actually have, and then sequence a little bit of this adapter sequence, which is not desirable because it will not map to any sequence on your genome, and it's always best to identify and remove this. So I want you to count the number of sequences that this file contain, this adapter sequence. So two things: count number of sequences in this FASTA file, and also the number of adapter sequence containing sequence, if that makes sense. Okay, so let's give this a try. You don't really need to paste any answer here. It's just more of like looking at the text file and see if you get something similar. So I know the first one a little bit might be a little bit you know, unsure as to how to go about doing that. But if you approach it in such a way that you want to count or some sort of pattern in the sequence file, that's not the way to go, because this sequence file will contain all your 4 bases or ends, and there's no unique unique value to each of these sequence. What you can use actually is to use this, I'm not sure if you can see, but this symbol, @ symbol, that is the first character of the sequence ID. And if I were to print out a little bit more of this line, like 20 lines, you can see that all the sequence ID starts with an at. Well, in this case, it's not all, because some of the scoring system, the Fred score, also contain an at. So you can also use at followed by the name of the accession that you are dealing with. That if you were to search for that at followed by SRR, at least SRR, that would be very unique to this particular line, and you're basically counting the number of sequences in the file. So let's try to do that. And I'm going to show you how to do this. We will do grep followed by at, and then SRR. SRR should be good enough. And then type in the name of the file, SRR173, and then save this into, no, we have to count first. So we have to do a WC, word count, and then an L, right? So this is going to count the hits from this search, and then save it into, I'm going to create a, let me see, a activity 5.txt. Right? We won't take too long. Let's see if I do a cat of activity. Again, cat prints out the entire thing, but since cat the file is actually very small, this is just one line, you do you are able to kind of print out the entire thing. So it's about 2 million lines. So it's about 2 million sequences in this particular FASTQ file. You can do the same thing for the other FASTQ file if you download it, and make sure that number of sequences between the two paired reads have to be the same. Okay. The next part is to count the Illumina sequences. So this is quite straightforward, because you just have to grep followed by, I'm going to copy paste the sequence of the adapter followed by SRR, and then again word count, and then -L to count the number of lines, not characters but just lines, and then override. So do a double opening double of this more than sign, and then specify the same file name as typo activity5.txt. Okay, so you can now cat the file again and see there's did I no, looks a bit weird, nothing's printed. Well, it's a good thing if there's nothing, but there should be something. There was a couple of sequences with this Illumina sequence. Let me see. No, sorry, I missed out. I have made a typo. See, this always happens when you don't pay attention. So there shouldn't be a head here. So it should be just WC-L and then followed by the printout to activity 5. So without a dash, without the pipe. So if I do this, that should be slightly better. And then, yeah, now it's better. So there are about 1,400 sequences that has this Illumina adapter. Yes, and then, yeah, I think somebody printed out 1433. Yes, that is exactly the answer. And you can determine if your sequences have this Illumina sequence in this particular way. You don't usually have to do that because it will be taken care of by downstream QC tools. But it's nice to know that you can find patterns. Cool. I'm just gonna stop here and just show you this image here without much description. I will talk about it next 2 weeks. And go through, I think I'll start off next week with this workflow. I'm just going to paste this here and then we can call it a day. I'm going to share, I've already shared the link to the image in Etherpad. So if you're going to click on it, I'm going to click on the link and share my screen as well to end this whole class. So it basically gives you a sort of workflow from the data obtained from the Illumina sequencer all the way to the functional analysis of RNA-seq experiment. Okay, as you can see, there's this part here that diverge quite a bit. For instance, on mapping, you have several ways to map depending on your desired outcome. So for next 2 weeks, we're going to use this quasi mapper called Callisto that will align the reads to the transcriptome. And then instead of doing this part whereby we annotate the type of transcript we have, we're just going to go straight into differential expression. But we're going to start off with Callisto first. Okay, so have a look at this. If you when you have free time, I'll talk about this again at the beginning of the next class. And one last thing, there are instructions on how to install at least 3 of these tools, one of which is FASTQ, Chemomatic, and then Callisto. It's not difficult, but it can be a hassle if you run into problems. So I provided 2 options. The easiest option is to use Conda or this mini Conda package manager. So give that a try first, especially if you're on a Mac, that should install quite well. If you're on Windows, I would suggest using the other method and try to install all these 3 packages if you want to follow along with the tutorial. Those who are having problems with Conda, you can also use the other method. That should be not an issue. But if you have any problems, just drop me an email and let me know what's your problem, and we will troubleshoot this before the class starts. So it's best if almost all of you have these tools ready, and then we can dive in and do the exciting bit and play around with the quality control. We will even trim directly. We will trim the RNA sequences and also map the sequences and get some sort of data from it. And I think it's going to be very exciting. So thank you for your time. It's exactly 2 hours, so we are on time, technically speaking. And any questions, I'll be here for a bit longer. If not, I wish you have a good day, and I'll see you in 2 weeks' time with the next part of the workshop.